Okay, so I'm going to create a new project in here of like unit 8. As usual, package will be just let's call it unit 8.arrays. Okay. Call it anything you want, doesn't really matter. And then we will create our main program without the constructor for now, and we'll use another type of class later on to do some objects. Okay. So again, arrays. So I mean, up to this point, you know how to store data in, I should say, mainly like just two ways, right? One is through using the primitive data types. We learned that way back in week 1 or unit 1, and you store data inside like integers, booleans, strings, right? And the thing is that those are primitive types, which means they can only store one data at any given time, right? At one instance, you can only store a single data. You cannot store more than more than one. Okay, so and then you learn about classes, right? Classes, you create objects out of that. Again, a class is nothing more than a template or a blueprint to create objects. And then with the class, with the object, you can actually store multiple types of data in there, right? Because within a class, you have an encapsulation of data, and inside that capsule, it's like a capsule. You have all kinds of data types in that object. So in a sense, it's like the object allows you to store multiple types of data. Okay. So in other languages, you might have learned the arrays first before you even get into the object-oriented approach. But in Java, somehow, because it's a full-fledged object-oriented language, that's where you're introduced into the object world way before the arrays. Okay. So now we're going to learn arrays. It's the third way of how you store data. Okay. So again, primitive type, you store only one type, one data at any given time. Objects allows you to store multiple types of data inside a single object. It's encapsulated. And then the arrays allows you to store a single type of data, but a collection of the same type. Okay, so that's the difference between those three. And so we have. So for this lecture or this chapter, we'll deal with only the single dimension or 1D arrays, and these are just very typical arrays. And so I'm going to put here 1D array, okay, or single dimension. Single dimension means like if you think of a table, we only deal with either a column or a row, right? It doesn't matter how you look at it; it's the same thing. Okay, so each of those cell is called an element of the array, and we access each of those elements using the array's index, or we also refer to that as the subscript. If you're familiar with math, it's the same thing. Okay, so arrays must store a single type of data. This is only true in Java and most strictly typed language. Okay? If it's a loosely typed like PHP or JavaScript, it doesn't matter what type of data you store. You can store any type of data in arrays. But for Java, it's only a single type. So in other words, you cannot mix, characters with strings, with numbers, and with booleans. Right? It's all either all integers, or doubles, or strings, or objects of the same type, and so forth. Okay. And you have like multiple ways of creating arrays and initializing arrays. So the first one here is I'm going to do what's called the uninitialized. I'll put here uninitialized arrays of you could use like unknown elements. Okay. What I mean unknown size. So the size means once you declare an array and once you specify size for the array, then That is fixed at that size. You cannot change the size, right? You cannot delete it. You cannot add more to it. You're stuck there. And that is also one of the disadvantages of arrays. If you know exactly what size you need, then that's perfect, right? If you don't, then you will leave it blank until a certain time, and you can initialize it, set that size. So array is, you would do this way. If you remember int numbers, right? A number, very typical. This is a single variable, store a single data type. This is a simple type, right? So to store a list of numbers, then you will put the array brackets right here, either right after the data type, and then because arrays are usually store a collection of items or data, then the variable names are usually declared as plural. Okay, so you have a list of numbers, you know, a collection of students' information, things like that. Okay, whereas the class, you see that class usually is a single object, so class names are usually singular. If you remember, we talked about that before. Okay, so this is how you initialize, or actually you declare an array of numbers, called numbers of integer type with unknown size. Okay, because I didn't specify the size, I can't use it until I populate it with some data. Okay, so in other words, I don't know what the size is. If you don't know the size, then you cannot access it, you cannot use it, right, until you specify size. So once you have this, let's just say that you have an unknown size, and then compared to something that has a size, I'll put one here. This one has a size of, we'll put, instead of numbers, we'll just say scores. Okay, it's also a number. So when you want to declare a size array, you put equal sign and followed by the word new, int, and then the size of that number in here. Okay, so it's like you're instantiating an object, but it is not an object really, but just a, well, it is because it's an array. Array is a reference type. Okay, even though these are we are storing primitive data types, it's an array, so that's why you have the new keyword there. So now I'm fixed at size 3. Okay, so this number here represents the top of the size of the array. This is the reverse of Visual Basic. If you ever taken Visual Basic, remember that when we declare an array of size 3 in Visual Basic, that is actually the upper bound of the array, the highest index. But in Java, because this is zero base and the way it does is differently, the upper bound number will be of index 2. So it will be whatever this number is minus 2. Okay. So in this case, this is a still an uninitialized, right? Uninitialized array of 3 elements. Okay. This is unknown size elements. It's not defined yet. Okay, so since I already defined the scores as 3 elements, then you can access or save data or populate the array. We call this initialization, or just populating the array by using the index number. So you can say now scores, for example, scores of sub 0 is equal to, if we put like 100% or 100 score on that, then you have assigned the value of 100 to that slot of the 0 index. And you always start with 0, that's the smallest size index, all the way to n, whatever that n size is. So there's no negative number. You cannot use negative number in there. Okay? And then, since I don't have the size of numbers, if you try to do the same thing with numbers, okay, numbers of 0 is equal to, let's just say we put 10. Okay, you see that there's a red squiggly line telling you that unknown size, or it's not initialized. It may not have initialized. It just means that you don't have the size in there. So before you can do this, you have to do something like this with the numbers. And for example, you could do a read from the console. It said enter a size of the array. Array, you enter a number, let's just say 5, whatever it is, that comes in, and then you can say a numbers equals new int type of size. If I put size, for example, if you read size, let's just say that you happen to read size from the input, you get a size of 5. Then now the array number has been initialized. It has been set to size of 5, and then from this point on, from like 15 downward, number now has a size of 5. So the size means the length of the array is 5 elements. Again, the max index would be a -1, so it'd be 5 minus 1, which is 4. Question?
So you cannot have, I know that in PowerShell or whatever like that, I can put however, you can leave the size of an array on 2 prime elements, and then the elements is used. You can't do that now. The array has to be of a certain fixed size.
Yes, before you can use it. So, you can declare it without any size, and you just wait until you get the size you want, and then you would say new something, and then that will be that size. So usually you do that by reading an input from the user, or are you reading from a text file of data, right?
So now, for example, I now want that to put in 10 form, I would then ask the user how many scores it is, and then initialize the array to that value, like you just did there.
Right, so once I put the size, that means that in memory, Java will allocate 10 slots in RAM. Whether you use them or not, it's there, it's fixed. Okay, you can't change it, you can reduce it, you can't add more to it. It's fixed at that size. Okay, and so now I can set the data to the first position, which is the index of 0. And if your index is more than your size, then you're going to have an issue, and you'll get an error said it's out of bounds. Okay, the out of bounds exception or the error will tell you that. So in other words, if I put like, because I know score is 3, if I try to put like scores of 3, which is out of bounds, put 90 here. Okay, in the program you see that it's fine. It doesn't give you any error until I run it, because this will produce what's called a logic error. A runtime error, I think. Let's see. So, as you can see, when I run this, and my code looks fine, no problem, I can put whatever number I want in here. Unfortunately, the ID doesn't tell me that. I should say, hey, 3 is out of boundary. But this ID doesn't give me that. So, until I run it, and then the exception handling detects that and tells me that at line 19, I have a array index out of bounds exception with number 3, and then that gives you a clue, and then you go back and you look at your code and say, oh, I initialized it with an array size of 3, so that means the index can only go up to 2. Okay, and so this will be a runtime error. Okay, so 2 is the largest size. So again, because it's a number type, integer type, I can't put like a float in here. Okay, if you put F for float or D for double, you will have an error, because the integer is such a smaller size than the float, and it doesn't have the capacity to store that size. Same thing if you store a character or a string in here. It has to be the same type only. Okay, so that's how you initialize or declare arrays to store those, to set the size, and then you initialize them line by line after that. So you can't go back and reinitialize in a different way. Okay, once I do this, like lines 11 and 12, then after that I can go into like score 0, and scores of 1 is equal to, maybe 85. And then 2 is 90, and then I do the same thing with the numbers. So you do that manually for all of them, and that could be tedious, right? So it depends how you do it. Sometimes you have to do it, sometimes there's other ways. Okay, so the other method here is to initialize, this is initialized array. Okay, so I can do the same thing. I could do int. So that brackets there, you can use the Java method or the C++ method. This is the Java method. I believe I haven't touched C for a while, but I think the C method would be like you put the brackets after the variable name instead of right after the data type. You could say integer of like, just say points, and you put the brackets after that. Okay, either way it's fine, however you choose to do it. Some people like it this way. I prefer the other way. I prefer this way because once I see this, I know exactly that that's an array. Whereas here, I mean, you will know too, but it takes you like, if you look at the end of that variable to determine that it's an array or not. Okay, so either way will work. Only when you do on the left side. On the right side, it's always the same. So we can initialize it at the same time by putting the square curlies over here and end that statement with a semicolon. Inside the curlies here, you can put any number size array you want. Again, it has to be the data type of integer. So I could say just points. I could be anything 90, and you separate each element with a comma, 45, 88, 56, and so on. Okay, once you end that statement, then the size of that array will be determined implicitly by the number of elements or number of data you put in that curly braces. Okay, so you don't have to specify the number there. Actually, it won't let you do it. Okay, so this is the other way to initialize data. So if you do it this way versus the way you do up here, this is actually much quicker and much shorter to initialize your array on the go. These are, of course, just constant numbers. Instead of this number 90, you could use these as variable name as well, right? You could use this integer variable name to store number 90 and so on. Or you can read that from the input and put that in there. But basically, this is how you initialize array on the fly. And then the size will be based on number of elements. Okay, so in this case I have 4. Size of 4, index from 0 to 3. Okay, so when you access each of these elements in the array, again, you could think this as a column or a row. It doesn't matter how you look at it. Until we deal with the 2 dimensions, then that's important. Which is row, which is column, that's important. But now it doesn't really matter. Okay, because these are just integer values, you can change the size. You can just treat this almost like a single primitive data type, which is true, right? It's a data type of int. So again, the points variable here is just a collection. It's like a bucket or a capsule that stores 4 data in there, right? 4 items of elements. And if you want to modify the, let's just say the 90 to something else, then you can say points of index 0. That's what the 90 is stored. I want to maybe if you want to add 10 to that score, then you can do plus equal 10, right? And if you look at the big picture, this whole thing here, it's just like the integer of size, I'll call size, f with size plus equal 10. It's the same thing, except you are actually accessing the first element, which is of index 0. Then you get the value of that, and then you multiply it, or you plus that by 10, and then you get a new value of now 100. Okay, so you can do all these mathematical operations exactly how you would do with the normal type, or the primitive type. You just have to make sure you are referencing the correct index position. Okay, otherwise you get something really weird. So in other words, you cannot do you can't do that, right? I cannot just say points plus or minus 10 because points is an array, it's a reference type, it's an object versus if you get it to a size, that's a primitive type. Okay, so you want to make sure you reference that particular array index. Okay, so to print them out, then very simple. you would just do SOUT to manually print each one of these out. You just say print system out print line, and then points, and then reference the index position, right? And that will print the value of 100 now, because it's we just added 10 to the 90, so now there should be 100. Okay, so if you run this now, Control F11, and see that it's 100 because we added 10 to 90. And if you print the next one, will be like the next statements would be points of 1, prints of 2 and 3, and so on. So an array, as you can see, I can do this like 4 times, which is a lot of hassle, right? Instead of doing that, we use loops to do it. That's what we learned loops like 2 weeks ago. And to print all the arrays, all the elements of the array, there you can use a while loop or a for loop, or any loop you want to use. It doesn't really matter. But since you know the size of the array, then it's usually very common to use the for loop to do that, okay, instead of the while. While are usually for something like if you don't know the size of the array or the loop, right? But if you know that, okay, I can determine that the points has a certain size, then I can say for int I, which is the counter of the index, starting from index 0, always start from 0. You don't have to, unless you don't want to. Let's just say I don't want to print the first element. I could skip that. That's okay. But let's just say everything in the array from index of 0 until the index I is less than the size of the points. So now I know that's 4. So I could say 4 here. But what if you don't know that, right? So if you don't know, you would say points.length. Okay. So points.length will give you the size of the array. In this case, it will be 4, the number 4. Make sure that the number 4 is the size and not the actual upper bound of the array size, which is the index of 3. Okay, so it depends how you do it. Your operations here will be really, you have to be careful with this. So if you put like equal, right, then you want to subtract 1 here. Okay, otherwise, you have a upper bound exception error as well. So either way. And then we want to increment to I++. And then we'll just print it out, so I can do just like this one here. So sysout, I want to print out all these numbers. So I can say points of I. Okay? And let me comment this one out. So that we'll have just 4 of those numbers printed out. It'll be 100, 45, 88, and then 56. Okay? So that's how you print out your all the elements in the array. One thing I want to point out is that the length property here in the array, don't confuse this with the length method in the strings. Okay? So if you want to know the length of the array, you can do like int len is equal to the points.length, right? That gives you a size of the array. And don't use that one. I mean, if you do, I think it's going to give you an error anyway. Okay, the length method is only applied to strings. So the size of the string, you use the length method, but array, you use the length property. So that's the difference. In other words, I put like string s is equal to apple, right? And the length of that would be string s length, and it's a function and not a property. So there are two. I know they are very identical in terms of spelling, but one is a property, one is a function, and this function applies to strings. Okay? So careful with that one. Okay, so that's the for loop. So with this for loop here, you can control, right? You can control the I, the index, and you can stop the index at any time you want. You can check for the index of I if it's, let's just say, if I is larger than 2 or 3, whatever it is, you can stop, right? You can break out of that. You can stop the loop. And then the other loop method is called the for each. This is the for each. Okay, or sometimes it's called the for in. I mean, different languages, like JavaScript, we call it for in. Or I think the book calls it the advanced for loop, or enhanced for loop or something. It's the same thing. But I think it's the for each is the more common one, for each and for in. So the syntax for that is you do like for, and then you will declare the data type, just like the first one here, int of type something. And since we're doing some points in the array called points, you can say for each integer called point in the points array. And this is why we named our arrays plural. Because when we use the for each loop here, you reference each element as a singular, right? Each single point of the points array. And then this variable point now actually stores the value of that first element for each of those elements in the array. And then now I can just print it out by saying system out print point. Okay, notice I don't have to reference the index at all, right? Because point will actually store the value of 100 already. Print that out, and then we'll go to the next one and print that out, and so on. So this way, you have no control of the array. You cannot know, unless you do some tests, you can. But if you just look at this, you can't tell when where you're at. So the idea for this one is just if you just want to print everything out from the array, then this is the preferred method. As you can see, it's much less to type, right? You don't have to worry about the another check the length, increment your index, and so on. It just prints everything from the beginning to the end of that array. And if you want to check it, of course, then you have to do the counter, right? Count of index, and then inside your loop, you can increment index by 1, and when it reaches a certain number, you can stop it. But if you do that, then you prefer using the for loop instead. Okay. So in other words, here you cannot manipulate the data. So in here I can say I print that out, and then I want to change the points of I to something else. I could do that, right? I could, because I have access to the index. Here I can't, because I don't know where I'm at, right? And to do that, you have to add another variable to count it, so you can change the value if you want to. So this is very common for arrays. Okay, any questions on this? So far so good? Okay, so we learned how to set the size of the array, either by initializing the array, and that will set the size for us implicitly by the program, or we actually just set the size manually, either during the declaration of the array, like number 3 here, or after that, right? Either way. So this is when I set size. This number 5 here could have come from the index, from the console, right? You do a read and just enter a number between 5 and 10, you put a number, and that's the size of the array. Now, the other way is, which is kind of similar to this one here, is that if you have a string of some data type. So let me just go down here, and I'm going to comment these out so we don't print these to the console. So let's go down here. Let's just say that, you can read this from the console if you want. Kind of similar to like we talked about last week about the palindrome, right? Read the string from the user input, and just say enter some words and put a comma separated. You split the string, and then you would grab those words. So let's just say that I have a string of called fruits, and I have apple. I separate each of those fruit by banana, cherry, and dates. Okay. And again, this is a string that I just declared. This could be coming from the user, or you might read this from a text file of data, a CSV file, or even from a database. Okay. So then, if you want to break this string into, or convert this string into to an array, because right now, in order to you to grab the word apple or banana or cherry out of it, it's kind of complicated, right? You have to go in there and search it and find the end of that character or the comma, and you take that word out. You grab a substring of that, okay, which is not very handy. You can, but it's just not as efficient as you change it to array. So I can say now I'm going to store this into a string array of unknown size, right? The size doesn't matter, and the array here is going to be called. Well, I have fruits already. We're just going to say data, okay? And then you will use the strings method called split of fruits. I'm going to split it, and I split at the comma. So it will find the comma, and we'll break that here, and put the first element into the first element of the array. And it will do that for the next one. Finds the comma, stops there, put banana into the second array position, and then the third and fourth, and so on. So when I run this, now data should store a collection of 4 elements, 4 items. Okay, and to see that, we can print it out. Say 4 again, int index. No, not int. I mean 4 of, let's say, fruit, right? For each fruit inside the data, print the fruit. Oh, not int. I'm sorry. It's a string type. Fruit is a string, not integer. Okay, so if you run this, you will see that we have an array of 4 items already split into its array position, except you have like a space in the front here. And that's because when you split by the comma, it still retains this white space, right? If you don't want that, then you can say comma space. That's one way. If you do comma space, then that should take care of that problem. Okay. This is not ideal. Usually you don't want to do that because what if I have like something like this, right? I'm going to have a lot of spaces here. What now? I'm still going to have that huge white space here. Okay. So what you should do is you just keep it as it was, and then when you print it out, or you can do another loop to clean it up, and you would say fruit, print the fruit dot trim. And you trim the white space around it. So you can put like here after banana, after dates, doesn't matter. You should trim at both ends, and then now the output should be very clean because all the white spaces will be trimmed off. Okay, but the comma is one of those important limiters. So here you can see that the size of the array is 4. So this is synonymous to what I just did up here in line 23, where I set the size by setting the data, providing some data, also elements to the array, and the size will be set implicitly by the program. So this is very handy for parsing strings into array. Like, for example, if you read or if you write a program to scrape some websites and read or grab all the HTML text file from a table or something like that, and you scrape through the entire text, and you would split the entire string of a string of the web page and split it by the comma or by a special character, and then you would access each of those elements in the array of n size. Okay? And that's how they do it when they write some scraper programs. Okay, let's see. Okay, so the next thing I want to talk about is parallel arrays. This is parallel arrays. Parallel arrays are used when you have a list of, let's say you have some items or some data about a particular person or things, but they're all different types, right? Because again, arrays can only store a single type. Let's just say you have some students, right? So I could say an array of students. You have the students' information, like the name, streets, and addresses. Those are fine, but those are all strings, so you can store them in there. But you cannot store inside a single array. You have to have a string array to store the student name, right? Just only names. You have another to store the address, and one to store the phone number, and so on. So you have something like that. And they all have to be kind of like, and have to have the same size, and they have to be related somehow. Otherwise, it makes no sense, right? So if you look about fruits, I can say fruits, all those fruits we had earlier, we can do something like that. So I could say string of, let's go with fruits again. I could just copy that one and put it in here. So, well, let's just do it again. So fruits, apple, banana, and then we have cherry. Let's just say there's 3 of those. Okay? And then we'll also want to know, like, maybe what the calories, for example, right? Calories now is in numbers or decimals or double points or floats, right? So we have, we'll just call this double calories. And so they have to match the index. Otherwise, that makes no sense. If apple has like 25 calories, then you're going to put 25 in here. If banana has, let's just say 30, and cherry has, let's just say 15.5. Okay? So they have to match. Just make sure they do, otherwise your data will be not consistent. And then we have another one here, double. Maybe, you know, the price, right, of each of these fruits. So again, will be numbers. Let's just say $1.50 for an apple, $2 for a banana, and $3.50 for cherry. That's pretty expensive, but yeah. You tried that before? Yeah. Yeah, I drove out there, but yeah, they were very expensive. They have a lot of apple there too. But. All right, so we have some data. They're consistent because they have the same size. Okay. So the idea is now you can create some information about the fruits and their calories and their price, and you can do more, selling price or whatever it is. And then you can use just a single index to track them, right? So if you're going to print them out, you don't have to say for a loop for the fruits, for the double, for the price. You can just do all in one take. So if you want to print them out, you can say like for int of I, start from 0, then the I will be less than the size of either one of those, right? Because they're all the same size. You can just pick one. I'll just do the short one. Price dot length. And then I plus plus. And then to print them out, I would say SOUT. I'll put here the apple will be fruits of I plus maybe like a colon, and then I'll put here next to it the calories. So the calories of I, and then we'll put a comma, and then space, and then we have the price of I. And that's it, right? I don't have to do like one for each because they share the same index and they're all matched. So the only problem, the only issue you want to be careful with this is make sure that the data are lined up properly. If you mix one of those, you can have a different price. And imagine if you run a website, you sell this stuff on the internet. Well, if you happen to swap the price on those, well, that's your own problem, right? The customers have the right to claim the price, or vice versa. If you happen to swap and then you make apples like really expensive and people buy a lot, you make a lot of money, but still, you have some inconsistent data. So if you run this, you'll see that the printout here, they have you can print this and make it more beautiful, but that's besides the point. Okay, so this is what's called a parallel array. Because you cannot break this out into a single array of different data types. Okay, so you can't do it. In JavaScript, you can. I could create a fruit, and inside that fruit, I could have a 2- or 3-dimensional array that have different data types. In Java, you can't do that. So that's why we would kind of fall back to objects, okay, for the object. But we'll cover next week the advanced arrays like list and array list and so on. Well, one thing about reference types, just be careful because reference is like object as well. Like we have a class of students or pets, whatever it is, and if you're not careful, you can actually overwrite your data. So what that means is, if I go back and right here, for example, right, if you're not careful, and let's just say that I happen to have another array, we call it new price, okay, and I just happen to say new price is going to be equal to price, and so the idea is that, okay, I want to copy whatever the price has, and then the new price will be have a different price. It's a price of 0. The apple is going to be not 150, but now it's 125. And then new price of maybe cherry has been changed to 325. Okay. Now what that happens is that because this is a reference type, then what I did here, actually I'm not copying, okay, only the data, but the memory address of the price. So I'm just basically pointing to the same memory location and what price is, and if I make any changes to the data and thinking that maybe I'm just changing the data from the new price, I'm not. Okay, so when you do this and you run, you'll see that the price has been changed from $3.50 to $3.25, and Apple is like down to $1.25. Okay, again, this is because they're reference type. Similar to what I told you about last week about mutable data, right? If you change one, it affects the other as well. So be really careful with the arrays because you can't undo these. Once you change it, it's changed. And if you want to make a copy of the array price, then you have 2 ways to do it. One is you do the hard way. You iterate through the price array one by one, and you copy each element over to the new price, right, array. Or you could do the shortcut by using the clone function inside Java. It gives you that option. So instead of saying new price, I would say price. Wait, is it clone price? I forgot I think it's price clone. Price clone. Yeah, you call that function, and then now you'll see that it should not affect the original price. Okay, so now I made a copy of price and clone it, and I copy not the memory address but the actual values only to the new price. So now I can change its value and so on. It won't affect the original price. As you can see, it will still say 350 and 150 for the Apple price. Okay, so the .com is a shortcut to do that. Otherwise, you have to iterate through the price, each of those, and then manually copy over. I mean, it's not that hard. You just do a loop like this for I as the price, the length, and then new price of I equal to price of I, right? That will loop through the entire array, and then it copies it over, and you get that new price. Okay. Iteration, we did that. Before loop, got that one. Parallel arrays. Searching the array, I think it's pretty straightforward. Kind of same thing here. Searching means just like you loop through the array and you check for every element of the array to make sure you have matching data. Right? If you want to search if banana or if a price is within a certain range or is within the array called price, if you want to search for all the $2 price items, then you can search through the array using that method. For I is 0 to the end of the array, you check each of those elements. You would say inside here, you would say price of I. If it's equal to 2, then grab the banana, which is the fruits of I, right? You get all those fruits out, all those calories out, and so on. Okay, that's basically searching through the array and make comparisons between them. It's also for like sorting purposes, right? So we'll do a very simple sort, and then we'll take a break. Here, let's see the price here. Oh, we can use the price. It's fine. So let's just say. Yeah, we use the price. And if you want to find out like the largest number in the price, the most expensive item in there, then how would you do it? If you look at the price array here, right? If you want to find out the most expensive price in that array, and then you basically do a loop, right? Do a loop. How do you find out which is the largest number in there? What do you think? What? You can't use those. Yeah, I think they have some built-in functions, but actually what you do manually or programmatically. So I'm just going to copy this one here really quick, right? So we go through the loop of the array of the price, and we have to like put a double of such as largest here, right? And we'll make that 0. Either 0, or you can make that as the first item on the price. You can make it 0, or you can, it's just default, right? That, or you could say price of 0. We'll assume that the first price is the largest. It doesn't matter. And then in here, you're going to check through every item in the price. So you can say if the price of I is greater than the largest price, which is the one we set. If that is true, then we want to set the largest price is equal to the price of I, right? And wrap these with the curlies. That's all, right? You just check for the largest price. If it is, and then swap it with the current price in the array. So first it comes through is 150. It is the same, so it's still the largest. And it goes back to the next one. It's $2 larger, so you will swap to the 2. And then 350 is larger, so that'll be 3, and so on. And as you print that out, largest will be just largest. We'll see that that should be just 3.5, right? So that's the largest. And if you want to find the smallest, same thing. Just swap the sign around. If you want to get a certain range, you compare, right? The price of, so you need to store the previous number and the current number, the current price, and the array, and compare those two, and I don't know, do something with them. Or also you want to check if the next element exists. If it does, then grab the next element and do the comparison. Otherwise, if it's the last item already, then you don't want to hold that one, because if you do, you get an out of bounds exception, right? Okay, so that's for the comparison and searching or do some type of manipulation in the arrays. Okay. And of course, once you find it, once you find this largest price, then if you want to know what that is, then you can then also get the fruit out of that and replace it. Because you can say like a string here, fruit is blank, and then it can say fruit is equal to the fruits of I, right? And that is the fruit that has the largest size. Of course, you can store the calories too, and so on. Let's say largest is that, and then you can say like plus, you put here maybe the fruits, fruit, then like that. I have duplicates here. Fruit, oh, it's not initialized. Put that to an empty string. Okay. So now, let's say the largest is 3.5 and it's the cherry.